Hi, everybody, and welcome to the 35th EACTS annual meeting, and also welcome to this Medtronic practical tutorial focused on the quantum heater cooler technology. My name is Jesse Wouters, and I'm Medtronic's Training and Education Manager for Western Europe. Together with my colleague Wim Snoeks, who is the Quantum Perfusion Technologies Program Manager, we are going to present on the quantum thermal technology, and at the end of this presentation, we are going to introduce you to an innovative product training that we created and recently launched, the VR Quantum Heater Cooler training. And we will introduce you that by using virtual reality. Before we really start with the content of this practical tutorial, let's share the objectives. We want to address the challenges associated with water-based heater cooler devices that are currently available on the market. We want to help understand why the quantum heater cooler technology is so innovative, and therefore we want to address the value of the quantum heater cooler to both clinical and non-clinical stakeholders. Last but not least, we want to introduce you then to the innovative VR quantum heater cooler product training, and we're going to do that by sharing a virtual experience with all of you. Before we dive more into depth on the challenges associated with heater cooler units, let's briefly mention why temperature management in cardiac surgery is so important. Cooling the cardiac surgery patients together with cardiopulmonary support provides several advantages. And one of these important advantages is that hypothermia reduces both the functional and the structural metabolic rates, and therefore can reduce the total oxygen consumption. This is already known for many years. Looking back to 1952, when Dr. Lewis closed by suture an atrium septum defect in a 5-year-old patient, and he used in this procedure moderate total body hypothermia. And when looking to the picture of that woman in the ice bath, well, Dr. Lewis actually used an ice bath for cooling down his 5-year-old patient at that time. The devices that we now use for temperature management of our cardiac surgery patients, they are called heater cooler units. We all know that. And according to federal health officials, they are considered as non-sterile devices. And in one of the next slides, I will address why this is. So now let's focus on the challenges associated with heater cooler devices, and to be more precise, let's focus on the challenges associated with water-based heater cooler units. The water that is inside the heater cooler unit circuits, this water does not come into direct contact with the patient's blood. But if the water is contaminated, there is the potential for this contaminated water to be aerosolized. And if this is the fact, bacteria can be transmitted via bioaerosols through the air and through the device exhaust vent into the operation environment and also to our patient. The main sites of heater cooler contamination includes the tubing and also the water tank. In this picture, I just want to state that water-based heater cooler units, they have been identified as a potential source of Mycobacterium infections. Heater cooler unit contamination with the non-tuberculous Mycobacterium strain was first described in Europe in 2014 after 6 patients were infected with this bacterium. And this led to an investigation of this outbreak. The fact that contaminated water can be aerosolized through the air and to our patients, well, this is something I already explained in the previous slide. Globally, the awareness of Mycobacterium infections is growing. Yeah? And up to now, we have over 120 cases published of Mycobacterium infections due to contaminated water-based heater cooler units. Mycobacterium infections is is hard and challenging to diagnose because clinical manifestations can take months or even several years to develop, and they are often non-specific. The most common manifestation of Mycobacterium chimera infection is endocarditis. And when a patient is infected, well, those patients, they have a pretty poor prognosis with a 5-year mortality rate of approximately 50%. In the next slides, I'm going to focus on the cleaning protocols provided by manufacturers of water-based intercooler units that are currently available on the market. I'm going to focus on the awareness of Mycobacterium chimera infections, and I'm also going to focus a little bit more into depth about the economics associated of managing Mycobacterium chimera infections. First, let's have an eye on the cleaning protocols provided by the manufacturers. And here you see a cleaning protocol of Livanovas 3T and Getinge's HU40 intercooler units. So both devices are water-based intercooler units. And as you can see in the green circle, well, we can conclude that these cleaning protocols are very intensive. Just as an example, every 7 days, we need to change the water of Livanovas 3T. We need to add hydrogen peroxide to the tanks and disinfect the overflow bottle. For the HU40 from Getinge, it's even more intense. Every 7 days, we need to do a routine disinfection. And well, this routine disinfection takes up to 150 to 200 minutes and so on. So after seeing these cleaning protocols and after discussing them with several perfusionists out of several hospitals all over the globe, I think it's fair to conclude that these cleaning protocols are too intensive and a real burden in terms of time and costs. Also, not all hospitals are following these cleaning protocols very strict. And this is probably due to still a lack of awareness, but also to a lack of resources, a lack of personnel, and no possibilities to create special cleaning rooms. Because don't forget, for doing these intensive cleaning protocols, hospitals need to set up special cleaning rooms with ventilation, etc. Also, we cannot forget to mention that when clinicians are following these intensive cleaning protocols, they are directly being exposed to the chemical aerosols. And in this way, it is also fair to state that Mycobacterium chimera does not act as a direct burden to our patients only, but also to our clinicians. The question now is, are these cleaning protocols provided by the manufacturers, are they effective? In this recent publication from a center in northwestern Italy, it was found that current manufacturer disinfection procedures, that they were effective in reducing all bacteria tested, with the exception of non-tuberculous Mycobacterium species. And I will call it NTM also later on in the presentation. So the resistance of these disinfectants could be explained by the ability that NTM species could adhere to many different types of surfaces, and they can form a so-called biofilm. And once this so-called biofilm has been formed, NTM species are extremely difficult to eradicate. The authors in this publication, they concluded that manufacturers' procedures for disinfections are ineffective and are inadequate. Let's focus a bit more on the costs of managing Mycobacterium chimera. This slide is, I'm showing you a recent publication from Marta and others, and they found that the mean cost of management of Mycobacterium chimera was found around 93,500 euros with two major cost drivers. On the first position, the increase of total length of hospital stay was an important cost driver, and on second position, the pharmacological treatment. Right. Let's go on. I've just presented the challenges associated with water-based intercoolers. Now it's time for introducing all of you to the innovative quantum heater cooler technology. And there's no better person for doing that than my colleague, Wim Snoeks.
Thank you very much. And thank you, Jesse, for your introduction of the system. And I really am happy to tell you a little bit more about the quantum heater technology and what this looks like. As we all know that the quantum heater cooler unit has a patented non-toxic glycol-based heat transfer fluid, which is proven to have bactericidal properties. And it has properties against a big variety of significant bacteria. The innovative design is a closed fluid circulation system and with a fanless cooling resource, which eliminates the potential transmission of the particles in the operating room. There is no intensive cleaning required, and thereby removing the exposure for the healthcare professionals for the exposure on hazardous and corrosive chemicals. So it means safety for as well the patients and the clinicians using the system. Here you see the conclusions or the answers of the cooler infection risk via its technological features. You have a glycol-based heat transfer fluid. The fluid is 30% glycol-based, and it's a non-toxic solution, which is also used in the food industry. Tests have been designed to determine the biocidal efficacy against clinical relevant bacteria. It's a closed circuit, which means there is no aerosols going out, and it takes place in a sealed space. The only contact of the fluid with air is controlled via a 20 micron filter. The phase change material is the cooling source. Big cooling fans, which are normally found in traditional heater cooler systems, are not used, and which is used to produce deep water cooling. They have been eliminated from the system. So the heat in the quantum heater cooler units is absorbed by the phase changer material block, which serves as the cold energy storage. So there is no laminar flow disruption. The system consists of a couple of critical elements. One of them is the heater cooler system itself, to be used with different sizes of disposable elements, and the cold storage charger, which is charging the heater cooler unit. I will elaborate a little bit more on the disposables in a later slide. So the hot and cold thermal energy is supplied using this glycol-based solution. You have to use two single-use sterile heat exchangers for both the arterial and the cardioplegia circuits. And they are used to convert the glycol circuit thermal energy to the patient perfusion circuit. There is no cleaning required other than performed by the Spectrum Medical during its annual Sentinel service plan. It's a fully functional standalone device or integrated with the quantum perfusion system and can be controlled directly from the quantum workstation. So the disposables, there's 3 standard heat exchangers for the AV loop, as we discussed, and 2 for the cardioplegia. The 3 standard heat exchangers are the high flow, the medium flow, and the low flow. The high flow is for adult use, the medium flow is for small adults and pediatric use, and the low flow is for neonatal circuits. Cardioplegia system, we have 2 sizes, one for the adult system and one for the pediatric neonatal side. The circuit is placed into the circuit. It's going after the arterial pump and before actually it enters into the oxygenator. The system itself is connected to the frosty heater cooler and is therefore cooled or rewarmed as needed during the bypass procedure. On the right side picture, you can see a picture as it is in place in the heart-lung circuit. On the bottom of the device, you can see the disposable heat exchanger used. So what are the take-home messages? As the world starts to look at what's coming after the COVID pandemic, we've seen different parts of the world turn their attention again to the issues posed by water-based technologies for patient temperature management. As a reminder, the Spectrum Medical quantum cooler is the safest, fast, and clean to use. Any water-based system, regardless of how it's disinfected, cleaned, or tested, will always be susceptible to contamination from the empty bacteria or other water-based pathogens, as Jesse just described. The Spectrum Medical quantum heater cooler is the first non-water-based heater cooler technology used in the world. The heater cooler is very silent, very powerful, and requires no cleaning other than performed during annual servicing. The quantum heater cooler is designed and indicated to be non-infectious due to the choice of using glycol-based solution. Well, thank you again for your attention, and I would like to give the word back to my colleague, Jesse Wouters.
Thank you, Wim, for introducing all of us to this very innovative quantum heater cooler technology. We're coming to the last part of this practical session, and we're going to take the opportunity to introduce you to an innovative product training that we recently created and that has recently also been launched. We're still dealing with the ongoing COVID-19 pandemic, and due to that, trainings like you see in these pictures, so trainings based on presence in clinical environments and trainings done in classes and wet labs, in many countries, this is still prohibited, and it's going to be, for a while, it's fair to state that trainings like these will be still mission impossible. Therefore, we needed to urgent transmission our current face-to-face TNE offers to digital learning. And already for a while, a lot of companies have been using different digital platforms like Zoom, Teams, and other platforms. With Imatronic, we explored a bunch of other innovative technologies available on the market, and virtual reality is one of them. And we believe by combining virtual reality to our current offers, either if it's digital or either if it's on-site when face-to-face trainings are possible again, we believe that using such innovative technologies, that this will optimize our training offers, better adapted to our customers' needs. And what we did is, the European Experience Center that is still located in the Netherlands, we created the European Experience Centers in virtual reality. And we created different rooms. So for example, in the picture here on top, you see the entrance hall, you see the conference room, and you see two pictures of the wet lab within the European Experience Center. We've also taken the opportunity of creating an intensive care unit. This room is still under construction, but it will be possible to train our healthcare professionals on our ECLS product portfolio in the future. In this practical tutorial, we're going to focus more into depth in the virtual operation theater. And to be more precise, we're going to focus on the VR quantum heater cooler training. Before I show you a recording of how this training really looks like, it is important to state that using innovative technologies like virtual reality, with Imatronic, we don't see this as it will replace any face-to-face trainings on site. No, we see it in a bigger step, and therefore we call it the 3 steps approach, but we see it as a mandatory step in a complete product training. Let me explain more in detail. For example, if you are interested to be introduced to the quantum heater cooler, or you want to test the device in the future, the only thing you need to do is connect with your local Medtronic sales representative. And then you will be scheduled for this VR training. What will happen then? Well, the Medtronic representative will provide you a special suitcase with all the VR equipment inside. And then the only thing you need to do is switch on the headset, take the controllers, and you will see that in a couple of seconds. And then you will be led through a multi-layered didactic product training. And during this training, you will be led through different steps, like you will be introduced to, in a theoretical way, to the product, but also to the therapy where this product is being used for. You will be introduced in how to set up the product, how to configure the product. You'll be introduced to the specifications of all the disposables, and so on. The VR quantum heater cooler training is therefore a completely individual self-training module and can be conducted in your own hospital facility. And you can do the training as much as you want. After completing this step 1, you are ready then for step 2. And step 2 is then the in-hospital hands-on training. Well, step 2 will go much faster and will be much easier for you, because thanks of this VR introduction to the product, you will already kind of know how the quantum heater cooler works and how to set it up and how to configure it, okay? And then the last step is providing support during a clinical case. All right, now it is time for some action, and I will play a recording for you to see with your own eyes how realistic such a VR product training really is. And you will see that everything that I'm doing in VR is completely realistic and identical of what I would do on a real quantum heater cooler system. So in this recording, you see in the camera view on top right that I'm putting my headset on and taking the controllers in my hand. And then this is Robot Eve, and she basically gives me instructions. When I complete an instruction successfully, she brings me to the next step. Or you can also choose to navigate through the menu and train yourself on the chapter that you want to be trained on. So for example, I want to learn more about the heat exchangers. So I'm going to position myself now in front of the table. And here on the left table, you see 3 arterial heat exchangers. On the right table, and I'm going to position myself a little bit better, you see 2 cardioplegia heat exchangers. Also, we have instruction tabs, which gives us more information about, for example, specifications about the disposables. So we're not learning only about the product itself, we're also learning about the therapies, about the different specifications. We learn everything what we need to know about the product. Now I'm going to transport myself into the operation theater. And we're going to use the heat exchangers in a real perfusion circuit. So I'm placing the arterial heat exchanger now in the perfusion circuit. I'm closing the holder, and then Robot Eve tells me that I need to connect the tubing parts to the blood inlet and to the blood outlet of this heat exchanger. Now I need to do exactly the same with the cardioplegia heat exchanger. So I'm placing it in the mounting arm, and then I need to connect also the tubing parts to the blood inlet and the blood outlet of that heat exchanger as well. Before we can now prime the heat exchangers, of course we need to connect the wide hose kit to both circuits of the quantum heater cooler and the outer ends to the 2 different heat exchangers. So I'm connecting one end to circuit 1 of the quantum heater cooler, and I'm going to connect the outer ends to the inlet and to the outlet of the arterial heat exchanger. I'm now going to do exactly the same with the cardioplegia heat exchanger. So I'm connecting the wide hose kit to circuit 2 of the quantum heater cooler, and then the outer ends I'm connecting to the inlet and the outlet of the cardioplegia heat exchanger. Okay. And now we are ready and we can prime the heat exchangers. For doing this, and I'm going to make the screen a little bit bigger for you guys, and Robert Eve just explained me that I only need to press prime. It is as simple as that. So I'm going to push on prime, and then we see that the heat exchangers are priming. Again, we have some other mandatory information tabs that we need to read through. And then if we have done that, we can actually see how the heat exchangers are being primed. We can see that in a close-up view, which you can see here. And we can see that on the heat exchanger in the perfusion circuit. And we just saw that the heat exchangers are turning blue, which is normal because the non-toxic glycol-based solution is a blue solution. Okay, so now the heat exchangers are primed, and now we can press the temperature regulation button. Okay, and again we have some information buttons, and now we can set our desired temperature that we want, and we can confirm, and then we see that our temperature is increasing till it reaches our desired temperature. One last thing that I want to show you guys in this virtual practical tutorial is I want to show you how to play with the configurations of the quantum heater cooler system. And for doing that, I'm going to transport myself back to the preparation room. So, okay, I will confirm, and now I'm back in the preparation room. I will position myself a little bit better in front of the heater cooler system. I'm going to make the monitor screen bigger again, and then I'm able to press the settings button, and we have two possibilities. When I press channel settings, I can enable or disable one of the two circuits and confirm. If I press the settings icon again and press unit settings, I can modify the screen brightness. I can increase or decrease the audio volume. I can I can select my preferred language, and last but not least, I can select the unit. Do I want to work with Fahrenheit or degrees of Celsius? This brings me already to the end of this practical tutorial. If you guys are interested in trying out this VR quantum heater cooler training by yourselves, well, I invite you all to meet us in the Hotel AC Marriott on the 14th floor in our Medtronic VIP lounge. If you're not present here in Barcelona, but you're still interested in trying out this VR product training, just connect with your local Medtronic representative, and we'll make sure you're scheduled for experiencing this VR quantum heater cooler training. I want to thank you for your attention, and I also want to take the opportunity to invite you for our second practical tutorial, which is scheduled tomorrow from 10 to 30. Thanks again, everybody, and both me and Wim, we wish you a nice rest of the day.